Okay, welcome back, Mr. Brown's revision. This is Year 12 Mechanics Part 4, Projectile Motion. Okay, this part's all about SUVAT and SUVAT equations. So first of all, what does SUVAT stand for? S is displacement, measured in meters. U is initial velocity in meters per second. V is end velocity in meters per second. A is acceleration in meters per second squared. And T is time in seconds. Okay, it only works, you can only use SUVAT if the object is undertaking constant acceleration. Now, what are the equations? Well, there are four ones that you're given in the exam. The first one, V equals U plus AT. The second one, S equals a half U plus V times T. Third one, S equals UT plus a half AT squared. And there's another one that's useful to remember, S equals Vt minus a half AT squared, followed by 4V squared equals U squared plus 2AS. Okay, let's look at some examples. So motion 1, just an object falling, accelerating due to gravity. Okay, so it's got initial velocity of 0 meters per second. It is falling at the rate of gravity, so that's 9.81 meters per second squared. So write out SUVAT and write down what we've got and question marks to what we know. So U is 0, V we don't know, A is 9.81 and T will say it's falling for 8 seconds. So we have 3 out of the 5, so we can work out the other 2. So for S we look for an equation without V, so S equals UT plus a half AT squared. So S equals 0 plus a half times 9.81 times 8 squared, which gives us 313.9 meters. Okay, motion 2, say for an object being launched upwards. Okay, so consider the motion by doing a little diagram. It's got an initial velocity upwards of 25 meters per second. It goes up to a maximum point and then falls down. At that maximum point, we know that its velocity is 0 meters per second and the acceleration is 9.81 meters per second downwards. So consider upwards movement first. So write out SUVAT and write down what we've got, what we don't have. So we don't know what S is, we don't know the max height, we know the initial velocity is upwards at 25 meters per second, let's make that positive. End velocity is 0 and it's decelerating, so minus 9.81 meters per second squared. So to find the maximum height, we're wanting an equation without T. So we use V squared equals U squared plus 2AS, plug the values in, so 0 equals 25 squared plus 2 times minus 9.81 times S. Rearrange that, we get 625 minus 19.62S, so rearrange it and we get S equals 625 divided by 19.62, which is 31.9 meters. Okay, so that's just in 2 motions. The third motion is a ball or an object travelling horizontally off a ledge. Okay, so a ball launched horizontally off a table in this case. So again, draw the little diagram to help you. So you've got the table, let's say that's 1.5 meters up, and the ball is going to be launched horizontally at 3 meters per second. Draw the path, sketch the path that it'll take, like so, and we don't really know much else other than. Okay, so what we need to do is we need to split it into its vertical and horizontal motion. I'd always like to draw a little table, so vertically on the left, horizontally on the right. Vertically it's accelerating due to gravity, so we use SUVAT here, okay, because it's accelerating. Horizontally we assume it's constant velocity, as we assume air resistance is negligible. So we write down SUVAT for the vertical motion and we write down SH, VH and T because we'll just use velocity equals displacement over time there. So first of all we need to work out if we're, well, let's say we're going to try and work out the horizontal range. So first of all we need to use the vertical motion to find the time it's in the air for. So we write down what we know We don't know the end velocity and we don't know the time, but we do know that it starts off at 0 meters per second downwards. So we use an equation without v, so s equals ut plus a half at squared. We substitute in, and we end up with 1.5 equals 4.905 t squared. So t squared equals 1.5 over 4.905. So t equals the square root of that, and you get 0.55 seconds. Now we've got the time, we can substitute it back in up there. Now in the horizontal motion, we've got 2 out of the 3, so we can find out the horizontal range now. So again, it's constants, velocity, so we don't use suvat, we just use velocity equals displacement over time. So SH, the horizontal displacement, equals VH times T, which is 3 times 0.55, which is 1.65 metres. Okay, part 4 is also projectiles, and what we're going to consider here is a golfer. So the golfer hits the ball at 70 metres per second, an angle of 10 degrees to the horizontal. So it goes up to its maximum point and then down again. Now what you need to do first of all is you need to split the initial velocity into the horizontal and vertical components, because it has both a horizontal and vertical component, because it's at 10 degrees to the horizontal. So to do that, the horizontal velocity is adjacent to the angle, so it's 70 cos 10, which is 68.9 meters per second, and the vertical velocity is opposite the angle, so that's 70 sine 10, which is 12.2 meters per second. So when we approach this, what we need to do is split into its vertical and horizontal component, but vertically we're only going to look at the first part of it as it's going to its maximum height. At this point it is decelerating due to gravity, so we use suvat. Horizontally, we assume it's constant speed, so we use velocity, displacement and time just. So write down what we've got. We don't know the displacement, but we do know the initial vertical velocity is 12.2 meters per second upwards. The acceleration is minus 9.81 meters per second squared because it's downwards, it's decelerating. The horizontal velocity is 68.9 meters per second, and we don't know the rest. So we need to find time first of all. So we find time using the vertical component. So we've got 3 out of the 5. We need to use an equation which does not involve s. So v equals u plus at. So plug the values in. 0 equals 12.2 minus 9.81t. So take the 9.81t to the other side and we get t equals 12.2 divided by 9.81, which is 1.24 seconds. So the total time of flight, because that's the time up to its maximum point, so the total time of flight is going to be double that, which is 2.48 seconds. Now we can plug that into the horizontal part. So 1.24 vertically up to the max, so 2.48 horizontally. So now we can find the horizontal range using horizontal range equals the horizontal velocity times time. So that's 68.9 times 2.48, which is 170.8 meters. Okay, that's enough for projectiles. So what we'll do is we'll have a look at some past paper questions. So I suggest you go away and you try this one, which is question 4, 2008, and this one, question 1, June 2004.